If you've used any of the modern AI agent frameworks like LangGraph, Crew AI, OpenAI agents, or any other framework, you might have noticed a pattern wherein the model thinks, makes a tool call, observes the tool result, thinks again, makes another tool call, and so on. But have you ever wondered where this idea actually came from? Turns out that all the modern AI agents follow a simple concept which was introduced in a paper called ReAct. And the core idea behind it is surprisingly very simple to understand. Instead of just reasoning, thinking, and answering, or just taking actions, ReAct combines both think, act, and observe, and keep on repeating. This simple loop is the fundamental concept behind all the modern AI agents. In this video, I'll be discussing what ReAct is, why chain of thought prompting or tool using agents weren't enough, and I'll also walk you through building a React style agent wherein you can see the pattern in action for yourself. So let's get started. So before we try to understand what React is, let's first try to understand the problems that React was trying to solve. So before React, we had techniques like chain of thought and tool using agents. If you don't know what chain of thought is, I would really recommend that you go and watch the video that is linked here, where I have discussed on different prompting techniques. So chain of thought basically focused on reasoning, whereas the tool using agent was focused on acting. So for chain of thought, there would be a question and it would go through a series of thoughts in order to come up with an answer. So models got better at reasoning tasks like mathematical problems. And for tool using agents, whenever there's a question, get the current weather, it would make a tool call to get the weather and return the answer, but it cannot reason through. If you're following the chain of thought technique, then if you ask it a question where it needs to make an external tool call, it won't be able to do that. Whereas if you're using the tool using agent, then if you ask it a question where you want it to reason, then the model might not be good at reasoning. And this is the problem that React solved. It basically combined both the techniques that are being used in these two chain of thought and tool using agent, which is reasoning and acting. React is basically a prompting paradigm which has two capabilities, reasoning and acting. In the reasoning part, it allows the models to think what it has and what it needs in order to come up with an answer. And in the acting part, it actually makes calls to different external tools in order to come up with the answer. So the typical loop looks like question, there's a thought, what do I know, what do I need? Then there is action, which tool I need to call. Then there is an observation, which is basically the result that you got from the tool call. And then repeat until the model is confident about the answer and then finally come up with the final answer. So now jumping to why thoughts are helpful. So first is that it is able to break bigger tasks into smaller tasks. So for example, if I ask an AI agent to book a flight ticket to Paris from Berlin and a hotel for the same dates, then its thought would be, okay, this task is too large to solve in a single step and it will come up with a plan. So it's basically here it's trying to break a bigger task into smaller tasks, which is very helpful for solving complex problems. Next is with thoughts, it is able to add common sense. Let's try to understand this with an example that if there's a question like, can I fit an elephant inside a car? Then the model, because it has the thinking capability, it will be able to come up with statements like, okay, elephants are much larger than cars. Then we might not be able to fit an elephant inside a car. Next is that because of thoughts, it is able to extract important information. For example, if I ask an agent who won the FIFA World Cup in the year when Lionel Messi first played in a World Cup. So let's say it goes, makes some tool calls in order to fetch some Wikipedia pages, and it's able to come up with a lot of data in those Wikipedia pages. But because it has the thinking capability, it might be able to come up with the information that is only relevant for the question we are concerned about, right? Instead of getting all the information, it will know that okay, the important information from all of this observation is just that Messi's first World Cup was 2006. Next is that with thoughts, you are able to also track progress. So if you have a query like plan a 3-day trip to Rome, then while the agent is trying to come up with the final answer, it might have lots of thoughts, and looking at any of the thought at any moment, you can say that where it has reached till now in order to finish up with your task. So, for example, for this, it might say, okay, I have selected the flights and accommodation. The remaining task is to create an itinerary for 3 days. So, this is very helpful. You are trying to debug an agent. Because of the thought, it's also able to recover from its mistakes. So, for example, if you have a query like what is the capital of the country where the Eiffel Tower is located, and let's say because of making some tool calls, it is able to get some irrelevant information that the Eiffel Tower is 330 meters tall. Now, this information is not relevant to the question that's being asked. So, because again, it has the thinking capability, it will take a look at this observation and say, okay, this is probably not relevant to the question that is being asked. Let me go and fetch the actual answer to the question. So far, I believe that you have understood that React is basically thought, action, observation, right? But there can be scenarios when you really don't want your agent to think every time there's an observation, right? So, for example, if you're trying to book a flight, then it needs to do a couple of clicks for booking the flight, and at every click it probably doesn't need to reason through. uh, Instead it just need to keep on going. So in those scenarios, React is able to adjust itself, and it is able to think only when it's required, and that is called as sparse React, wherein there's a thought, action, observation, and if a thought is needed, only then it will think. Otherwise, it will just keep on going, right? And contrary to that, there is dense React, where you need the agent to think every time there's an observation. So then the trajectory that would be followed is thought, action, observation every time. So now we know almost everything that we should about React. So let's go and try to build a React agent. Okay. So here I have done some setup. Again, I'm using Olama. I am using model Llama 3 here. I have defined certain tool definitions that I will be using for demonstrating a React agent. So I have created a knowledge base, which is just a dictionary with some keys and values. Of course, in a production system, it's not going to be like this, but just for the demo purposes, I have created it like this. I have defined tools like calculator, get current date, knowledge based lookup, and yes, I have put all of these tools in a dictionary again. Then I have a React system prompt. Then there is a parse action, which is basically used for parsing the response that we get from LLMs, because the LLM's response will be a string, and then you need to find the tool name from that, or the actual uh, parameters that you need to pass to that tool, etc. So you can write your parse action. Here I have written the parse action, which extracts the tool name and the arguments that needs to be passed to that tool, right? Then this is my React agent, which is basically um max steps. Here I have defined as 8. Configurable, you can change it to whatever you want, but max steps here basically means that okay, if you don't find an answer after trying for like 8 steps, then you just stop, right? And here I'm going through the max steps loop and making a call to this chat API from Olama, and I have this assistant message, basically the response from the AI assistant, which I'll be parsing and checking if I already have the final answer. So if I have the final answer, then I'll just return from here. If I don't have the final answer, then I'll keep looping and I'll probably extract tool name and the tool arguments that I need to pass by calling this parse action method. Then if I have the tool name and the tool is present in the tools, then I'm actually making the call to that tool so that I'm able to get the observation. Observation is basically the result from the tool. So whatever the tool returns will be present in this observation variable, which you can print it. Then finally, you can just append all of these messages like the observation that you got, keep on appending in your conversation history so that the agent has the context. And if there's a tool error, then also you can append it. Otherwise, if there's no tool, then you don't need to take any action. And if max steps are reached and you could not come up with an answer, then yeah, it will say that max steps reached without a final answer. So here I have shown a couple of examples. So first one is where it's trying to ask this React agent. Again, the Eiffel Tower has a height. If you stack four of them on top of each other, what would be the total height in kilometers? And you can see that in step one only it was able to find the answer. That's very good. Um, the best part is that here you can actually debug what was the thought that the agent had and then what action it took based on that thought and what was the observation. So you can see that the thought was, I need to know the height of the Eiffel Tower, which is correct, and then multiply by 4, completely correct. Then it says that for that I need a calculator by 4 and come up with the final answer, right? So final answer is that it will be 1.3 kilometers. Okay. And similarly, another example is I'm asking this React agent that Amazon was founded in 1994. How many years ago was that from today's date? So for this, it might need to use two different tools. One is the date tool that we created, and the other one is the calculator for calculating the difference in the number of years. So we have already the state tool and calculator tool. So I'm expecting that it will go and make a call to these tools. You can add debug statements in order to see if your tool is being called or not, like I have added here. So for this one, you can see that it took like 3 steps for it to come up with the final answer. So first thought was that I need to find out what today's date is, and then it took the correct tool and it was able to find out, okay, today was June 2nd, 2026, and then same process it did for thought Amazon was founded in 1994, so I need to calculate the difference between 1994 and 2026. Perfect. And then again, it took the correct tool that it needs to, and finally, it was able to come up with the final answer. Okay. Then there is another example where I'm asking how long in seconds does it take to travel for the light to travel from Earth to Moon round to two decimal places. And as you can see, it was again able to come up with a final answer. So similarly, you can create your agent. You can make it do many more things. You can create a lot of other tools where you are making external API calls or database calls or whatever you need in order to for the agents to get to the answer. And yes, play around with this. The link to this notebook is in description. I hope that you got to learn something from this video. If you learned something, then don't forget to hit like and subscribe to my channel. Thank you.